So in this session, we'll do the Doppler and the pulse echo technique questions. In question number 1, there is a source which is emitting out a frequency Fs. So this is actually the frequency which is emitted out from the source Fs. And it is accelerating towards the observer. It's moving towards the observer. Its speed is increasing. So the question is, the F naught or Fo is the sound or frequency of a sound heard by or received by the observer. So what will happen? Source is emitting out a frequency, like if I say source is emitting out frequency of 200 hertz. But because the source is moving towards the observer, so observer will not receive the same frequency from the source. It will receive the higher because it is moving towards the observer. So it means the frequency which is received by the observer will be greater than the frequency which is emitted out from the source, and greater as well as increasing. Why increasing? Because they are mentioning accelerating. So accelerating means continuously the speed is increasing. If the speed is increasing, so the continuously the frequency will start to change. Like first it receive, if it was moving with a constant speed, there will be a constant change in frequency. But continuously there will be a change in frequency because the object is accelerating towards the observer. Another question. Over 40 years ago, Apollo astronaut placed a reflector on the surface of the moon. So on the surface of the moon, they place a reflector. This is the Earth. So there is still use by number of observations on Earth to monitor the distance between the moon and deflecting the pulses of a laser light from them and detecting the reflected light. So what happened? Like example, astronaut placed the mirror on mirror on the moon, and the laser pulse is sent. Like example, this is a mirror. So the laser pulse is sent, and when it bounces back, we receive that, and we can use it to determine the distance between the moon and the Earth. So the scientists have determined that the moon is at a distance of 363,104 kilometer at its closest and 405696 kilometer furthest. So I mean this distance is not constant, this distance is changing. Like the closest one is 363104 and the furthest is 405696 kilometer. It has also been determined that the moon is getting about 3.8 centimeter further away from Earth each year. Like every year, the moon, this is like it's getting 3.8 centimeter away from us. Describe how the reflected pulse can be used to determine the distance to the moon. So how the reflected pulse can be used to determine the distance. So we can use a formula that speed is equals to 2d divided by t, or we can say the distance is equals to speed multiplied by time divided by 2, where s is the speed of a pulse which is known, which is constant, that is the electromagnetic radiation or light rays there, so 3 into 10 power 8. And what about this t? So we can record the time. T is the time for the return trip. So T is the total time, like time to travel and return back, and that product divided by 2, we can get the distance between the moon and the Earth. The next part, an observatory send out the pulse of a light duration 2 into 10 power minus 8 minus 10 second. when it is used to determine the distance to the moon. Calculate the pulse length. So we have to calculate like what is the length of the pulse. So length of the pulse is basically a distance traveled by the pulse divided by time. We can get the length of this pulse. Or basically if I calculate the wavelength, that is also refers to length of the pulse. So we have the formula, like if I want the length of the pulse, if we need d distance, so we have the formula speed is distance divided by time. So length of the pulse is basically how much the length of the pulse is this distance. It's not always a wavelength because pulse is not like always a wavelength. It can be a half pulse, it can be a quarter pulse, it can be 3 by 4 pulse. So it can be any length. So the length of the pulse, this distance is refers to length of a pulse. And how to know length of a pulse? If we know the time, like example, the length is taking the time it took to move from one position to another, it is 2 into 10 power minus 10 second. And the speed of the pulse is already known because we are using a laser light. So a light wave which have a speed of 3 into 10 power 8. So how much distance traveled by the pulse is known as the length of the pulse, which is equals to speed multiplied by time. It does not have anything to do with this concept because length of a pulse is basically a distance traveled by the pulse in a duration of the pulse is known as the length of the pulse. So speed is how much? Speed is 3 into 10 power 8 multiplied by time interval. It is 2 into 10 power minus 10. So when we multiply, it will 3 multiplied by 2, 6 and 10 power 8 and minus 10. So it will be 10 power minus 2 meter. So the length of the pulse is 6 into 10 power minus 2 meter, or we can also say it is 0.06 meters. Is it clear the concept of length of the pulse? Length of the pulse means the distance traveled by the pulse. So distance traveled by the pulse in a pulse duration, that's known as the length of the pulse. Then discuss whether the level of the precision quoted for the distance to the moon and its rate of increasing distance of Earth are justified. Like as they mention here, the increasing the distance from the Earth to the moon is increase. Like we are saying that the distance between the moon and the Earth is increasing. So how we can justify or whether the precision which is mentioned here, like it is mentioned that 3.8 centimeter it is moving every year. So whether it's like 3.8 centimeter compared to the total distance which we calculate, so is it like comparable distance or what percentage of precision is there? So basically the distance is given in kilometer, whereas the distance move, the distance which is moved by this is about 3.8 centimeter. Like example, that's a distance which is moved by the, we say that every year the moon is moving at a distance like what is now, after 1 year it will move 3.8 centimeter away from us. So whether this is justified or no, so it is not correct. Why it is not justified? Because what happened if this is the earth and this is the moon? Example, this is in 2020, and after 1 year the moon has moved to a distance like 3.8 centimeter away from us. So whether this distance is justified, like it is can we say it is precisely measured? So we'll say no. What is the reason why? Because you can answer in two manners. Number one, because the original distance were measured in kilometer. Like this was in kilometer, this is also in kilometer, and the distance which is moved by the earth, distance which is moved by the moon is in centimeter, or a very small proportion is there, so it won't be precise. That is one thing. Second, you can compare the pulse length, because whenever we determine the distance, the pulse length should be smaller than the distance between the two objects. So when we compare the position in 2020 and 2021, so it has moved 3.8 centimeter away. But the pulse which we are using is 6 centimeter. So 6 centimeter pulse cannot accurately determine the change in the 3.8 centimeters. So that's why it won't be accurate. So you can compare in terms of pulse length. If the pulse length is longer than the distance change, it means it won't be accurate. If pulse length is shorter than the distance change, then it will be accurate. That's one way. Or you can mention the distance which is given here is in kilometer, where the change is in centimeter, so it won't be accurate. Is it clear that how we discuss whether this is precise? Then the next part, the round trip for a light takes about 2.5 seconds, and as many as 10 pulses per second may be used. Like we can use 10 pulse in 1 second. State why pulses are used rather than a continuous beam. Like why we are using a pulses, sending one wave, then sending another, then like after certain time. Why not we are sending all of the wave like continuous wave? So the advantage of using a pulse, so we can tell which pulse is received and matches with the send pulse. Like example, we send one pulse, then we compare when we receive that pulse, then we send the second pulse, so that we can tell which received pulse matches with the send pulse, or identify the start of the pulse with reference to another feature. So we can compare the pulse which is sent with the received. Then in question 3, which of the following would allow the level of a detail in ultrasound scan to be increased? Like if we want to make more detailed image, what we should do, we should reduce the wavelength, or we should reduce the length of the pulse. So for question number 3, increasing a duration of the pulse. If we increase the duration of a pulse, because the pulse length is speed multiplied by time. So if we increase the time interval, like the distance traveled by the pulse, it means the time interval of the pulse, it means the distance will increase. If a distance will increase, it means the pulse length increase, or detail of the image will decrease. Increasing a high frequency, because if we use a high frequency, it means the wavelength will be shorter, and shorter wavelength will give us more detailed image as compared to longer wavelengths. Increasing the intensity does not have anything to do with detail of the image. It is like how much radiation has returned or bounced back, that will affect intensity. And increasing a wavelength, again it reduces the detail of this image. So engineers are developing a system using the Doppler effect, which will detect the movement of the people in the room during a hostage situation. The system make use of Wi-Fi transmitter already in the building rather than needing a separate transmitter. So the system shown in the diagram, so like in case of a, like inside a building, in case of a hostage situation, so these Wi-Fi transmitters can be used to identify where the exact location or the position of the hostages and identify their motion with whether they are moving towards or away from the source. So a detector is placed outside the room, receive a signal directly from a Wi-Fi transmitter. So this is a wall, a detector is placed outside along a path XZ. So detector is receiving signal directly from transmitter X, then also receive a signal reflected from the person in the room. So there's also another Wi-Fi signal which strike the room and bounce back. Explain how the system uses a Doppler effect to detect the motion of a person. So how, because look, one he is receiving directly. So example, that is example 200 hertz, the frequency. But the one is striking the person and bounce back. So if the person is moving away, the frequency which he receive will be shorter frequency like 150 hertz. But if a person is moving towards, the frequency which he receive will be a higher frequency. So how the system can use a Doppler effect? So first thing, the system will compare the relative or the change in the frequency. So due to the motion of the person, like if the person is moving, there will be a change in frequency or the wavelength. And compare the change in frequency. If the frequency increase, it means person is moving towards. If frequency decreases, the person is moving away. If frequency is same, it means the person is inside the room stationary. So compare with signals from X. If the frequency increases, so it means it is moving towards. And the third mark, the last point you will mention, if the signal from a person receive is having a low frequency or the frequency decrease, it means he is moving away. State an advantage of pulse echo technique over this system. So like why, what is the advantage of using a pulse rather than a continuous wave? So I can be identify like, because pulse echo can be used to identify the distance, it can be used to identify or calculate a distance between the source and the object. So if you use a pulse echo technique here, what is the advantage of pulse echo technique over this system? Like this is one of the system, but we can also use a pulse echo technique. Pulse echo technique, why it will be more effective? Because the signal sent and signal received, so we can use speed is equals to 2d divided by t. So distance will be speed multiplied by time divided by 2. We can get the distance. So pulse echo technique can work for a moving object as well as stationary object. Like if this object is moving, what is the distance of object at particular moment of a time can be determined using a pulse echo. But Doppler effect can only work with a change. Like if there is a no change in the frequency, like if a person is stationary, if person is at position Y or another position, like example A, another position B, so all the cases the frequency which is received from X and the one which bounce back and receive from A, or the one which bounce back and receive from B, they all have the same frequency because the person is not moving. So we cannot determine, we can say he is in a state of rest or he's not moving, but we cannot say the exact position of this person, because Doppler effect is only effective for determining the speed of a moving object or change in speed for a moving objects. So pulse echo technique will work for stationary as well as moving objects. Is it clear? Discussion? So in next session, we will do more questions related to the Doppler effect and the pulse echo technique.